Okay, let's look at the first example here. We have using exponents, what is the simplified form of the expression 4 to the 5th times 4 to the 2nd? And these exponents really mean repeated multiplication. So what we're looking at here, if I have 4 to the 5th, I have 1, 2, 3, 4, and 5 of those multiplied together, which are also multiplied by the 4 times 4, which is the 4 squared. Okay, and so how many do I have here total? I should have 1, 2, 3, 4, 5, 6, 7. That should be 4 to the 7th power. And so another way to remember this, if you are multiplying equal bases, such as the 4's here, all you need to do is add the exponents. 5 plus 2 is 7. And we're looking at choice A. Please stay tuned for the question to follow this example. Okay, looking at another example with exponents. In this case, we have negative 5 raised to the 3rd power. Something interesting about this question is that the negative 5, the base, is in parentheses. What that means is it means we have negative 5 times negative 5 times negative 5. It means keep the negative with the base when we multiply these together. So right here, this should give us positive 25. Now, bring down your negative 25, or sorry, your negative 5. So when we multiply positive 25 by negative 5, we should get negative 125. That is our answer. The difference here is if we did not have parentheses, if it was just simply negative 5 cubed, what that would mean is 5 times 5 times 5, get the result, 125, and make it negative. This example here, because the exponent is odd, does not make a difference with the negative being included in the parentheses. However, if that was an even exponent, the answer would have been different. Okay? So just as a reminder, in an example like this, make sure if the parentheses are around the whole base and there's a negative there, include the negative with your base when you multiply things out. Please stay tuned for the example to follow this question. Okay, looking at another example of exponents. In this case, we have which expression is equivalent to or equal to the same as x to the 8th raised to the 9th power. Well, because I have two exponents here, what this means is I have 9 of these x to the 8ths. So if I were to write that out, x to the 8th 9 times, then what I would do is go through and use our rule where if I multiply equal bases, we add the exponents. I have how many of the 8s? I have 9 of them. Okay, so if I add 8 to itself 9 times, I will get x to the 72. Okay, the connection here, 8 times 9 is 72. So our rule was anytime we have the power of a power where there's an exponent raised to another exponent, multiply those exponents together. And so our answer here should be choice D. Please stay tuned for a question to follow this example. Okay, let's look at this example here. It says, which expression is not equivalent to 6 to the 3rd divided by 6 to the 6th? First of all, I would like to know what is 6 to the 3rd divided by 6 to the 6th. So if I were to figure that out, I would say, well, because I'm dividing equal bases, I am going to subtract exponents. This becomes 6 to the 3 minus 6, which hopefully we know is 6 to the negative 3rd. Now, how do I change an exponent that is negative to a positive exponent? Why do I want to change it to a positive exponent? I don't know how to multiply 6 by itself negative 3 times, but I could do it positive 3 times. So what we do, if you recall, we take the reciprocal. And so the reciprocal of 1/6 is, 6 over 1 is 1 over 6. All right, the exponent stays with the 6. And it changes its sign. So 1 over 6 to the 3rd is the answer here. That's actually what 6 to the third divided by 6 to the sixth is, but we're looking for what is not equivalent, okay? So what's not equivalent? Well, that is equivalent. 1 over 6 to the sixth, 6 to the third is. So even though that's actually the answer, we want to know what's not the answer. So part D is out. 6 to the third is actually 216. If I were to multiply it by itself 3 times, it's 216. So that's out. Okay, and we did find that 6 to the negative third right up here was an answer as well. So that has to be out. Therefore, that should tell us by process of elimination we are looking for 1 over 6 to the second. That is not the same thing as what we found with 6 to the third divided by 6 to the sixth. Okay, please stay tuned for a question to follow this example.